Hello everyone, welcome to my channel C.S.E-Pathshala. We were studying about machine learning using Python 3, and in this tutorial we will study about random data distribution. So in the previous tutorial we have already studied about random numbers, how to generate random numbers, and how to pick up random numbers from a given array. In this tutorial we will study about random data distribution. Alright, so what do you mean by data distribution? Data distribution is a list of all possible values and how often each value occurs. For example, we are having a list, and a list comprises of certain values, and also it is representing that the number of times that particular value has been occurred in a list. So if we talk about data distribution, it is very much important when we are working with statistics, with data science. And if we talk about NumPy, NumPy offers random module that returns randomly generated data distributions. Alright. Now if we talk about random distribution, so random distribution is a set of random numbers that follow a certain probability that is called as probability density function. So what does this probability density function means? It is a function that describes a continuous probability. That means probability of all values in an array. So this probability density function represents that we have been given an array of values and each value is associated with certain probability. Okay, so we can generate random numbers based on defined probabilities using a choice method. We have already seen choice method in the previous tutorial also, where we have seen that with the help of choice, we can pick up a number from a given array. So a choice can also be used in a random module, and with the help of choice, we can also specify the probability of each value which is present in an array. So if you talk about the probability is set by a number between 0 to 1 obviously, and the 0 means that there is no occurrence of that particular value, and the 1 means it's a 100% occurrence of that particular value. So in order to implement this thing, let's consider a code. That means we have been given a problem to generate 1D array that contains 100 values, and each value has to be like 3, 5, 7 or 9. And the probability of each value is given as for 3 it's 0.1, for 5 it's 0.3, for 7 it's 0.6, and for 9 it's 0. Alright, so let's consider a code from here and implement it on Jupyter Notebook. Alright, so here it is. Import NumPy as NP. From NumPy import random x equal to random.choice. So we are importing NumPy first, then random module from NumPy, and then we are using random module along with the choice. That means random.choice. Here we are giving an array. Okay, here we are giving probability of each value present in an array, and here we are giving the size. Size means we have again seen this thing in a previous tutorial also. That means this parameter tells that with how much dimension you need to print these particular values, then we are printing it. Okay, so let's save this code, run this code. Alright, so here is the output. So we have seen that a 1D array has been printed. Okay, and all the numbers like 3, 5 and 7 are printed with respect to their probabilities, but a number 9 has not been printed because its probability is 0. So obviously, if we run this program as many times as we can do it, let's save this code, run this code. So every time we are going to see some different output, but never we will see 9. Okay, again just save this thing. Okay, and run this thing. So again the output is different, but there is no 9 present here. Alright, so the sum of all the probability numbers would be equal to 1. It should have to be like if I just talk about these 0.1 plus 0.3 is 0.4 plus 0.6 is 1, and rest is 0, so it's 1. So probability should be equal to 1 in form of a sum of whatever the numbers which are given in an array. Okay, now even if we run this code 100 times or 1000 times, 9 will never occur. This we have already seen. And we can return arrays of any shape by specifying the shape in the size parameter. We did with this program in a form of a 1D array, but we can enhance it also in a form of 2D array like this. In the next example, we can see this thing. We have to return a 2D array with 3 rows and 5 values containing in each row. So we need to modify size. So how we will do this? Let's consider a code and implement it here. Alright, so import NumPy as NP. From NumPy import random, x equal to random.choice, and here we are taking the same list of elements, same probability of the elements, and we have just modified size, that is 3,5. It means that we need to print 3 rows and every row must consist of 5 elements. Okay, so let's save this code, run this code. So here it is. So these are certainly the elements which has been printed in a form of a random manner. So again, we can save this code, run this code. We expect every time a different output. Okay, but no 9 is present here also. Okay, fine. We can also perform random permutations, and random permutations of elements can be done in a manner that, as we know, a permutation refers to an arrangement of elements. It's a mathematical concept, and in a permutation we can somehow arrange elements in any manner. Okay, for example, if we have been given a list like 1, 2, 3, so the possible arrangements for this can be 3, 2, 1, 1, 3, 2, or 3, 1, 2. So certainly these are some possible arrangements. We call all these as a permutation. So in NumPy random module also there are 2 methods called as shuffle and permutation. We can perform these 2 methods. Let's consider the first, that is the shuffling of the arrays. So what does actually shuffling means? It's clearly specified that shuffling is the changing arrangement of elements which are present in an array. Okay, so let's consider an example first. Randomly shuffle elements of the following array. So let's consider this code and implement it here. We need to shuffle the array elements. So import NumPy as NP. From NumPy import random, arr equal to np.array. Here is your NumPy array. And then random dot shuffle arr. So we are using random module here, shuffle method or function here, and we are giving arr as an argument to it. Okay, and then we are printing it. So let's save this code, run this code. So here it is. The values of array are shuffled in a random manner. Okay, let's save this code again and run this code. Now the output is different, and we can again save this code. Okay, and run this code. Now the output is again different. There is one more thing. Let's print your array also before shuffling. Okay, so here, alright, so let's save this code again and run this code. So your initial array was like this, and the shuffled array is like this. Okay, so if we shuffle the elements of original array, change has been reflected. If next time we print the shuffled array, obviously it will be a new array. Alright, now if we talk about permutation method, we can generate a random permutation of elements of the same array which we took in the previous example. Let's consider this also. Okay, so here it is. Alright, so import NumPy as NP. From NumPy import random, arr equal to np.array. This is your NumPy array, and we are printing this array in a form of like random dot permutation arr. That means we are doing some sort of arrangements with this array. And let's print original array also, print arr. Okay, so let's check the output of this. Save this code, run this code. So here it is. So this is the permuted array, and this is your original array. One thing we have noticed, that original array is same, while we did permutation of the original array, it is different. Okay, it is signifying us that when we use shuffle, the changes are reflected on the original array, but when we are using permutation, changes are not reflected. So again, let's save this code and run this code. We will expect some different permutation. Alright, we got some different permutation again, but the original array is same. Alright, now this is the difference between shuffle and permutation. Now if we talk about Seaborn, Seaborn is used for visualize distributions and it is a library that we uses in Matplotlib, and Matplotlib is also a module of NumPy which is used to plot graphs. And this is how we can visualize the random distribution. Here we have been given a graph. It's a continuous graph, and here we can see the probability density of the elements which are present on this axis. Okay, so we can plot such kind of graphs with the help of Seaborn and Matplotlib. Okay, so how to install Seaborn? If you are having already Python and pipe installed on your system, so you can easily install Seaborn with the help of a command like this: pipe install Seaborn. And my Python is installed in C drive. So I just took this path and just wrote this one statement, and installation has been done. Okay, so you can also do in a same manner. All right, in Seaborn we are having Distplots. Okay, so what does this Distplots mean? Distplots stands for distribution plot actually, and it takes an input array and plots a curve corresponding to the distribution of points which are present in the array. Okay, all right, import Matplotlib. So we can import pyplot object of the Matplotlib module, okay, in our code with the help of following statement like this: import matplotlib dot pyplot as plt. Okay, and then if you want to import Seaborn, we can do like this: import the Seaborn module in our code with the following statement like import Seaborn as SNS. Fine. Now we'll start with a Distplot. Okay, how to plot it? Let's consider a code, then we will understand. So here it is. Import matplotlib dot pyplot as plt, import Seaborn as SNS, and then we will draw distribution plot. First we will consider an array whose for the values which we need to have a plotting. So SNS dot distplot, here is your array, and then we are just showing what we have plotted. So plt.show is being used from Matplotlib module, and Distplot is used from Seaborn module. Okay, and yes, we can, let's save this code and run this code. Okay, so all right, here it is. So here a warning has been coming, which is just telling that we are using Distplot here. So in future versions it may be eradicated, so it's okay right now. It's been functioning very cool. So we can see a distribution plot here with our values. Here on x-axis we have taken our array elements, and here is the probability density of these particular elements. So here is a histogram. We can see a curve like this. It's a continuous curve, and here we can see a histogram. Histogram is representing that we have taken the values from 0 to 5, so it has been shaded like this. Okay, and yes, this is how we can perform the plotting. Okay, now if we don't want to show histogram, so we can make it as false. Okay, so how we can do this thing? Let's consider a code again. Alright, so here it is. Import matplotlib.pyplot as plt, import Seaborn as SNS, SNS.distplot. Again we are taking the same elements, and we are making histogram as false. So whatever the shading which we have seen in the previous example, that the values which we are looking for this graph, it will not be shaded right now. Okay, histogram will not be printed, and yes, we are just plotting it. Okay, so let's save this code, run this code. Alright, so here it is. Again a warning is coming. This is because of Distplot, so please ignore it. And here is your graph. So yes, it's a clear graph and continuous graph. All the values has been presented here, and the density is also been presented here. Okay, so this is all about random data distribution. We will come up with more exciting lectures. Thanks for watching. Kindly do subscribe to my channel.